Hello children, let me take 7th class maths, the second chapter, fractions, decimals and rational numbers. So before going to this topic, let us find out what is today's proverb. The today's proverb is, need teaches a man. What do you mean by this? Need means necessity. Necessity will definitely teach you a lesson. Usually, when you have some work to do, if it is not so important to you, you will just take it for granted that okay, I can do it afterwards. But in case if you feel that yes, it is very urgent for me, very necessary, there is nobody to help me, I have to do by myself. If you develop that kind of thought, what happens, your mind will definitely cooperate with you. It will stop thinking about anything else and it starts thinking about the solution of your problem. And definitely you are going to get a perfect solution for your problem. Same thing you can apply to your studies, children. You should have that feeling that it is necessary for me to learn these topics for my future. I need to learn. If you take that determination that I must learn and I should get it, when others of my age group are able to learn and get the good marks, why don't I? Even I can. See, God has given brain equally to everybody. There is the intelligent people will not hold a very big brain and a small adult students will have a very small brain. Internal structure of brain is same to everybody. But why others are not scoring good marks? Because they are not feeling that it is necessary. They are just taking it for granted that if I get leisure, I will do. Or I am not interested. If you wander, if you remove this kind of thoughts from your mind, and if you feel that it is necessary for my future, I should become something great, I need to learn, definitely your mind will help you, children. That is what they say. Necessary teaches a need teaches a man. It definitely, when you start thinking about it, just you start doing that, children, then immediately what your mind says, yes, let me understand this, let me learn this. So concentration will develop. Definitely your marks will improve. Definitely you will score good marks. Okay, children, let us come back to our topic. This is about rational numbers we are doing. Now we are going to talk about equivalent fractions. Equivalent fractions. This can also be written as equivalent rational numbers. So whether they are fractions or rational numbers, they are equivalent. What is meant by equivalent? The definition is fractions with different numerators and denominators. Fractions with different numerators and denominators, but obtain the same value after simplifying are called equivalent fractions. Equivalent fractions. So this can be considered as the definition of equivalent fractions, children. What are they? The fractions with different numerators and denominators. Numerator is different and denominator is different. Just when you have a look at it, we feel that they are different fractions. But when you simplify them, Simplifying means what, children? I have already explained you about co-primes. If you have a number, if you can cancel numerator and denominator with the same number, you can do it. That means what you are doing? You are getting co-primes after simplifying. So like that, after simplifying, if you end up with the same value, same answer for all the fractions, then they are called equivalent fractions. It will not be the case with every fraction, children. Only a set of fractions are like that. So that kind of fractions are called equivalent fractions. So with the help of example, you will understand, children. Suppose I have taken 2 by 4, 3 by 6, 4 by 8, 5 by 10. So children, let me simplify each one here. 2 by 4. 2 ones are 2 twos are. How much I am getting? 1 by 2. 3 by 6. 3 ones are 3 twos are. 1 by 2. Then 4 by 8. 4 ones are 4 twos are. 1 by 2. 5 by 10. 5 ones are 5 twos are. 1 by 2. So children, all these fractions are ending up with 1 by 2, 1 by 2, 1 by 2, 1 by 2. So, when you are simplifying, you are getting same answer. Therefore, these fractions, what are they? Therefore, 2 by 4, then 3 by 6, 4 by 8, 5 by 10 are, they are called as equivalent fractions. They are called as equivalent fractions. So, what you are having? They should get the same value after simplifying. That is what the definition says. Fractions with the different numerators and denominators. See children, numerator 2, 3, 4, 5. Denominator 4, 6, 8, 10. They are different. But obtain the same value after simplifying. Each one I am simplifying. I have divided it with the same whatever table with which they can cancel. So when I have divided it, I have got answer as 1 by 2, 1 by 2, 1 by 2, 1 by 2. That means what? After simplifying, they all are having same value. See, same value they are having. This kind of fractions are called as equivalent fractions. I hope you have understood, children, about this definition and what are equivalent fractions. If you understand this only, you can do the next problems. Copy this, children. Now, the next one, after equivalent fractions, let us go for now page 56. Do this. You have to go for do these sums in page 56. The first one, write 5 equivalent fractions, rational numbers. You have to write 5 equivalent rational numbers. So the first one is given as 5 by 2. 5 equivalent means what, children? First you take 5 by 2 and multiply with the same number with numerator and denominator. How much you are getting? 10 by 4. Again, 5 by 2 into 3 by 3. 15 by 6. 5 by 2 into 4 by 4. 20 by 8. Next, you need 5 now. So 5 by 2 into 5 by 5. 25 by 10. 5 by 2 into 6 by 6. 30 by 12. So 1, 2, 3, 4, 5. All these 5 are 5 equivalent fractions that you have drawn between for 5 by 2. And second bit is given as minus 7 by 9. So minus 7 by 9. How will you write, children? Minus 7 by 9 into 2 by 2. Minus 14 by 18. Minus 7 by 9 into 3 by 3. Minus 21 by 27. Minus 7 by 9 into 4 by 4. Minus 28 by 36. Minus 7 by 9 into 5 by 5. That is minus 35 by 45. Then minus 7 by 5 into 6 by 6. How much you are getting? Minus 42 by 13. So, this is children 1, 2, 3, 4, 5. So, 5 equivalent fractions you have written for this. So, anything you can simplify it. When you simplify, 3 7s are 3 7s are 3 9s are 4 7s are 4 9s are. This is the easiest way of writing the equivalent fraction, children. When you multiply both numerator and denominator with the same value, you are going to get this. So I hope you have followed this. Please copy. Do this problem, children, in page 56. Now, we will go to the next one. Page 56. Do this. Now, the next one. Identify equivalent rational numbers in each case. You have got first bit, you have got first bit. The second problem of do this first bit. Minus 1 by 2, minus 3 by 4, minus 2 by 4, minus 4 by 5, 4 by 8. Now, you have to identify equivalent fractions. So, the first and foremost thing what you can do is write the simplified form. 1 by 2 minus 1 by 2 means it itself is simplified form. Minus 3 by 4 also is itself simplified form. Minus 2 by 4, you can write 1 and 2, minus 1 by 2. Minus 4 by 8, what you can do? 4 ones are, 4 twos are. It is also minus 1 by 2. What did you do? The given fractions you have simplified first. Means you have put them, converted them into co-primes. Now you see which of them are having equal values. Those are equivalent fractions. The problem is identify. So what is the answer? Equivalent fractions. Equivalent fractions are, what are they? See, wherever you are getting 1 by 2, minus 1 by 2, and again minus 1 by 2 you have got for minus 2 by 4, and you have got it for minus 4 by 8. So, these are the equivalent fractions in the given values. See children, how simple it is when you are able to simplify them. Directly if you see, you may find it difficult to identify what is correct, what is wrong, what are the like ones, equivalent ones. So you simplify them. Then wherever you are getting the same answer, all those are equivalent fractions. This is something else. You cannot simplify it further. So it cannot be considered as equivalent fraction. Now, copy children. Now, second bit. The second bit is 1 by 4, 3 by 4, 5 by 3, 10 by 6, 2 by 4, 20 by 12. So, like what we have done earlier, let us see. 1 by 4 itself is a simplified form. 3 by 4 also is a simplified form. 5 by 3 also is in simplified form. They all are co-primes. Now, go for 10 by 6. 2 5s are 2 3s are. So, 5 by 3 you have got. 2 by 4. 2 1s are 2 2s are. You have got it as 1 by 2. So, 20 by 12. See, 10, 20, 2 10s are 2 6s are. 2 5s are 2 3s are. So, you have got 5 by 3. 4 5s are 4 3s are also you can do. So, what are the equivalent fractions, children? Here. What are the equivalent fractions? So here 1 by 4 you have only one place, 3 by 4 also one place, 5 by 3. So what all are 5 by 3s? You see, this is 1 5 by 3, then this is also you are getting 5 by 3, and this is also you are getting 5 by 3. So these three are equivalent fractions. So how did you identify them, children? Only after simplifying. Otherwise it is difficult. So I hope you have understood, children. Copy this. Now we will go to the exercise 7. In this exercise 7, write any 3 equivalent fractions. You have to write 3 equivalent fractions. So what are 3 equivalent fractions? For first one, 2 by 3. How will you change, children? First one, A. 2 by 3 into 2 by 2, 4 by 6. B. 2 by 3 into 3 by 3, 6 by 9. C. 2 by 3 into 4 by 4, 8 by 12. See, children, these all are the 3 equivalent fractions. When you simplify, you are ending up with the same 2 by 3. So, you can write equivalent fractions in this way, children. This is easiest method for you to write the equivalent fractions. Next, second bit, minus 3 by 8. So, how will you write, children? Minus 3 by 8 into 2 by 2. Minus 6 by 16. Minus 3 by 8 into 3 by 3. Minus 9 by 24. Minus 3 by 8 into 4 by 4. Minus 12 by 32. So these are the 3 more equivalent fractions, children. So if you, when fractions are given and ask you to find out whether they are equivalent or not, divide them, simplify them and identify the same fractions. If a fraction is given and ask you to find out equivalent fractions for it, you multiply numerator and denominator with the same value, you are going to get the answer. That answer will be definitely the equivalent fractions. If you want, you can check. 4 by 6, 2 2s are, 2 3s are. 6 by 9, 3 2s are, 3 3s are. 8 by 12, 4 2s are, 4 3s are. So this is how you can write equivalent fractions, children. So I hope you have understood. Now we will see the second problem. Second problem is, what is the equivalent rational number? What is the equivalent rational number of minus 15 by 36. Equivalent rational number you have to find out. Equivalent rational number means what, children? With the denominator, they have given equivalent rational number with the denominator. They have given denominator first bit. Denominator is 12. So you have to write another equivalent fraction for it. Minus 15 by 36 should be equivalent to some other fraction with 12 as the denominator. If it is having 12 as the denominator, children, how should you find out the numerator? If you read this table, you will be getting this number, or you can divide 36 divided by 12, 12 3s are 36. What is this value that you have got? You multiply it with 15. 15 into 3, that is 45. So if you write 45 here, see 15 3s are 45. Okay. Sorry, you have to divide it. If you write 15, it will be more. So with this 3, what you have to do? You have to divide it. 3 5s are 15. 5 3s are 15. 12 3s are 36. 5 into 3, 15. 12 into 3, 36. So with which number these two should be multiplied, that you will have to find out by dividing. So 5 3s are 15. 12 3s are 36. You can cancel 3 5s are 3 12s are. So 5 by 12 you are getting. So you need to get denominator as a 12, children. The fraction should be, the denominator should be 12. That is possible only when you divide these two and identify with which number it is, means what is the number with which if you multiply it you will get this. 12 3s are, see, small numbers means directly you can think about the table. 12 table you can think. Suppose you have got a bigger values. Then what is the procedure for identifying the number? What you have to do? You have to divide this by this if this is a big number. Then what is the value with which it is to be multiplied to get this, you will understand. With the same number with which this should be, you have to find out, search for a number which with that number if you multiply by 3, you should get this. 15 I want means I need 3. 3 into 5 is 15. So I need to write 5. That means if you divide 15 by 3, 15 divided by 3, I am getting 5. So that 5 I can write it here. So first you divide 12 by 36, you have got 3. This 3 and 15. If you divide it, what are you going to get? 5. So 5 is the 5 by 12 is the value that you are getting with the denominator 12. So I hope you have understood, children, because specifically they have mentioned the denominator as a 12. We need to type denominator as a 12 only. So if you read this table, because this is smaller value, if you read this table you should get this number. 12 3s are 36. So sum number into 3 is 15. What is that sum number? 5. 5 into 3 is 15. So 5 by 12. So simple ones orally you can do, but if it is a bigger one, this procedure you follow. Divide 12 divided by 36. 3 you have got. Take this and divided by this number. 5 you have got. Smaller values means this calculation is not needed, children. But procedure if you know, if you get higher, bigger numbers, you can go for this procedure. That's what, that is why I have told you this. Now, let us see the second bit. What is the second bit? The second bit here is minus 15 by 36 should be written with numerator minus 75. So minus 15 by 36 is equal to minus 75 by. So how are you getting 75, children? 75 with which number if you multiply? 15 5s are 75. So you have got 5. So 15 is multiplied by 5 to get 75. So take 36 and multiply by 5. 5 6 are 30, 15 and 180. 17 per 70 minus 75 by 180 is the equivalent fraction for it. I hope you have understood, children. If denominator is given, you are dividing. If numerator is given, you are multiplying. Procedure you understand, children. Now let us go to the third one. Third problem. Mark the following on number line. First bit 1 by 2. As I have explained to you, children, each one I will write separately. See, this is a proper fraction. Earlier I have explained. Proper fraction will be between 0 and 1. 1 by 2. So, 2 parts you have to make. So, this will be 1 by 2. So, you have represented this in the number line. And second one, 3 by 4. So, it is once again 3 by 4 is a proper fraction. So, it also lies between 0 and 1. Denominator is 4. So, divide into 4 parts. 1, 2, 3, 4. 4 parts. Let me divide it equal parts. So, 1, 2, 3, 4 parts. So, this is 1. So, this is 1 by 4, 2 by 4, 3 by 4, 4 by 4. So, this is 3 by 4. You have represented 3 by 4 on the number line. Now, the third one is 3 by 2. 3 by 2 is an improper fraction. So, when you do it 1 by 2. You have got the denominator, you have got the mixed fraction conversion from improper fraction 1 by 2. So, since it is 1 by 2, what are you getting? 1 by 2 means first you have to draw it. It lies between 1 and 2, children. 1 and 2. Since denominator is 2, divide it into 2 equal parts. So, this is 1, this is 1 by 2, and this is 2 by 2. So, this is 1 by 2 means 3 by 2. So, this is the representation. Now, copy this, children. Fourth bit, I will do it in the next afterwards. So, I hope you are understanding, children, about this. Already I have given you explanation in the previous video. You can go through that also, children. Proper fractions always lie between 0 and 1. Improper fractions, they lie after 1 at any place. Which place it depends upon. After converting the improper fraction into mixed fraction, you will understand between which numbers you need to keep that number. After identifying between which numbers, write those numbers and see the denominator. How many parts you have to divide, the denominator will say. After dividing, very easily you can locate. Okay, children. Now, let me do the fourth one. Fourth bit. Fourth bit is 10 by 3. So, 10 by 3 means what, children? 3, 1 by 3. If you have doubt, go for the division. 3 3s are 9, 1, 3, 1 by 3. That means what, children? This number lies between 3 and 4. The integral part will tell you between which numbers the number lies. So, this is 0, 1, 2 and 3, and I will write 4 here. I need to keep a gap because I need to fix this number. Denominator 3. So, I have to divide 1, 2, 3 equal parts. So, this becomes 3, 1 by 3. This is 3, 2 by 3. This is actually 3, 3 by 3. 3, 3 by 3 means it is 1, that is, it becomes 1, 3 plus 1, 4. So you see, these two are 4. So 3, 1 by 3. Where is 3, 1 by 3? This is 3, 1 by 3. 3, 1 by 3, otherwise called as 10 by 3. You have represented 10 by 3 on the number line. I hope you have followed, children. I have done this. Next. You have got fourth one. Fourth one is true or false. I'll say the answer, children. Every integer is a rational number and vice versa. Every integer. Fourth problem. True or false. Every integer is a rational number and vice versa. Every rational number is an integer. Rational number cannot be written as integer, children, because integer is having 0. In integer you are having 0. We know that rational number should not have, when you are dividing p by q, where q is not equal to 0 we are writing. So 0 cannot be considered in integers. So you will consider this as 0 cannot be considered in rational numbers when you are considering rational numbers as integers. So it is a false one. Next, what is the second one? Second one, a rational number in the form of p by q. Q must be non-zero. P by q, q must be non-zero. Yes or no? Q should not be 0. Non-zero means q must be anything else except 0. So we will say it is a true statement. Now, the third one, 5 by 7, 6 by 7, 7 by 7 are equivalent. They are saying that they are equivalent. Is it true, children? No, it is false. Why? Because denominators are same but numerators are different. And you cannot simplify. They themselves are the simplified ones and they are not representing the same value. Then the fourth bit, equivalent rational numbers of a positive rational number are all positives. Equivalent, yes. Equivalent rational numbers that is equivalent rational numbers of a positive rational number. Means when you have taken a positive rational number, its equivalent rational numbers are all positive. Yes, it is true because you cannot take negative values. Okay, children? When you are taking, suppose you may ask me, minus 2, minus 4 can be taken as 1 by 2. But minus 2, minus 4 you are not supposed to take. Negative values means only either numerator should have minus or denominator should have minus. So in that case it is not possible. So it is a false statement. So with this I am going to conclude my topic, children.